Welcome back to the next part of the introduction of Oli Tycoon. Oli Tycoon is the third game in the RetroRemakes project in Unity. In this part of the introduction we want to take a look at two special screens. The screens contain minigames of Oli Tycoon, and the first one is the drilling minigame. We will take a quick look at the minigame and how to get there. When you go to your computer and you buy an oil field, and for example you select a region and a sector, then you first have to buy a concession for that region, then you can buy an oil field here and you are asked if you want to drill. You confirm this with yes and choose to drill on your own and not hire a specialist. Then the minigame will start and you see that you have this new screen opened where you have three windows. The main window is showing the earth layers you have to drill through. The second window shows the scanner. Here we have the cursor that needs to be centered in the middle so the drill does not deviate from its correct path. And here we have a magnification of the drill that is similar to the earth layers you can see here. The drill is going down in that window as well. There are several attributes that are shown here in the main window. The deviation means how far you are off from your center. The status indicates how dangerously far away you are from your optimal path. When you're in the middle, the status is excellent, and so on. Then you have the pressure. You can add pressure to the drill or release pressure from the drill. So the more pressure you have, the harder it is to control the drill, but the faster the drill goes. And you have a firmness indicator that tells you how firm the current earth layer is. For example, here we have a rock layer that is very firm, and the firmer an earth layer is, the harder the drill is to control. A lot of the logic is handled in the code, and we will take a closer look at the code, of course, in later videos. So for now, I will just give you a brief introduction how this screen is set up. We can find it here in the hierarchy, drilling screen, and we open this up. You can see these three windows, the drilling frame, scanner frame, and the drill frame on the lower right corner. Like all other screens, the drilling screen has a script drilling screen where all the logic is handled. It also has a few references to components it needs. When, for example, a new earth layer is reached in the drilling and the firmness changes, the script needs to know where the firmness indicator is, and so the script can adjust the firmness indicator accordingly. These indicators are just images, and they are tiled images, meaning when we make them a bit wider, they will tile, and you can see here the base graphic is only 4 pixels wide, 2 white pixels and 2 transparent pixels, and you can see the width we set to 90 pixels, so that is the equivalent of 90% of this whole bar. So in the code you can adjust the width to make this bar a little bit smaller or wider. The drilling screen also has references to the drill, of course, because when we fail to drill and the drill breaks, we change it to another sprite. This one here. And the most interesting part in this screen are the earth layers. The isometric earth layers are the ones in the main window, and the flat earth layers are the ones in the lower right window. So let's jump to one here in the hierarchy. You can see they are grouped under one game object, and basically all these layers are just images and they all have the same image attached. This one here, it's looking a bit funny maybe, but this represents the shape you can see here. And this is set up as a sliced image. Let's take a quick look in the sprite editor. And this means only that part here, the middle part, should be scaled when we scale that sprite. the lower part should stay the same. And why that is important, we will see when we analyze the screen when the game is not running. So here you can see, for example, there are 5 layers. The last layer is the oil layer, you can see down here. And the image used has white and gray colors, so it can be colorized. For example, for the last layer, the color is black to represent the oil, but you can change the color, and in that way, each of these earth layers are colorized. Depending on the region and the sector you are drilling in for your oil, you will have a different constellation of layers. For example, when you're drilling in the Alaska region, you will have a snow cap here, and the first layer will be ice. And when you're drilling in the ocean, you will mainly have water layers. This is configured by using scriptable objects, and we will take a look at them in the next video. One other thing that changes dynamically is the amount or the percentage each of these layers takes. So the composition of the layer depends on the region, like we said, but there is a randomized percentage for each layer to keep it interesting. For example, if you are drilling in the desert, like here, you will have an earth layer, and then you have a sand layer and a rock layer, but the amount of the layers can vary. So let's take a look at the topmost layer, meaning the layer that gets rendered on top. It's the brown layer here. We can toggle it on and off, and depending on the percentage that layer has in the whole composition, the height of the layer gets scaled. For example, if we scale this up, you can see the amount gets bigger and the layer below gets smaller. And the scaling effect is achieved because we have set our image up to be a sliced sprite. So when the screen is shown and the minigame starts, the layers are set accordingly and the percentages are randomized, and then the heights of each layer are adjusted. And you can see that each of the layers, each image is attached to the same anchor point and are scaled from the top. So when 2 of the layers have the same percentage amount, like the 2 layers here, by eyeballing I would say they are similar enough, you can see in the first layer the height of 49, and the next does not have a height of 49, but it needs to be a lot higher, because let's go back to 49, then it would render another top layer, and it will only show when it is higher than the 49 pixels. So that is calculated in the code, and all these layers are set accordingly, and the last layer is the oil layer. Of course, it has to be the highest one so that it is shown at the lowest part. The same idea is used in the drill frame with the flat earth layers. Here you can see you also have the layers here. Since we are zoomed in here a bit, the scaling is a bit different, but the same idea applies. And when the game starts, not the drill is moving down, but the earth layers are moving up. You can see it here when we move the Y position. It creates the effect that the drill is going down. While the drill is going down, you can see this white bar, and the way that is done, it is just a white pixel scaled to the height of 74, and we set the image type to filled. And when you do that, you will have a fill amount slider, and over the course of the drilling it is just animated from 0 to 1. And once we reach the oil, we have the black line to simulate the oil going up, and this is set up in the same way. The white pixel is just colorized to black, and the fill amount is set to 0 at the beginning, and when the oil rises, it is scaled up to 1. So that is the basic idea behind the drilling minigame. The next screen with the next minigame is pipelining screen. You can see it here. And the pipelining minigame shows up randomly when we want to sell oil, sometimes you will get a message that there is a problem with your pipeline and you have to help out. And because that is a random event, maybe it is a bit harder to test, because if you start the game and you start selling oil and the event won't pop up, then you need to sell oil a few more times. So I just added in the context menu of the pipelining screen script a new entry. You can just take a function in the script and annotate it with the context menu attribute. Let's take a look in the code real quick. Don't worry about the complexity here. We will take a closer look in other videos. Here is the start game method that is called internally, but we also have this attribute context menu start game. That means we have now in the context menu of the script this entry, and we can call that function directly from here. So we first need to start the game, of course, and then we can call this start game method from here. And then you can see here the arrows indicate from where to where you have to go. And when you're ready, you can start clicking these pipes and lay your pipeline until you reach your destination. Let's pause for a minute and take a closer look at the screen. Here in the script, you can see there are several references to sprites that are placed on the playground. You can also configure the color for the player and the computer. You play against the computer, by the way. And you have references to the images for these buttons, so you can colorize them as well as needed. Then you can see we have grid tiles and grid tiles computer. The way the game works, let's take a look at the terrain frame. That is the main frame here. When we fold it out, we have terrain tiles, terrain holder for computer player and terrain holder for the player. And the terrain tiles, you can see these are 42 images, and they are grouped by using a grid layout group. When we select one image, you can see they are grouped here. The first 7 images are laid out horizontally, the next and the next row, and so on. And right now the terrain tiles are just desert tiles. But you can make it more interesting by inserting a river, for example. Then you would need to change the image here to a nice river or something else. Or you can change the color. And for the change to appear, you need to advance one frame. But that is the basic idea behind the terrain tiles. Then the computer and the player have their own tile images. And they basically work the same way. At the beginning, only the first image here has this pipe image, and the last image has the equivalent in the lower right corner. And the other tiles are transparent sprites. So in the beginning you will see nothing, but of course you will see the terrain under this layer. And whenever the player clicks on a button and lays a pipe, for example on this tile, we change the transparent sprite to the according pipe sprite. And the computer has their own tiles, because in this game we want to be able to occupy the same spot on the map. Here you can see we have a pipe here and the computer also has a pipe here. And to see that the computer has a tile also at that position, the offset is a bit different here. You can see the computer tiles are nudged a bit to the top so that they are not completely covered by the player tiles. Once the player reaches this tile or this tile, it is considered a win. And when the computer does the same for its destinations, then it is considered a loss for the player. But luckily for us, the computer has made a mistake and built against the wall and can continue. And like I said, to lay a new tile, we have these buttons here. And what they do is they call functions in the pipelining screen script. For example, here lay pipe vertical or lay pipe horizontal and so on. and the pipelining screen will check if this is a valid move. For example, we can't lay a horizontal pipe here at that position. We need to lay a 90-degree angle first, and the script also calculates the positions where the new tile will get placed. For example, when we take a look at this sprite here, then the next sprite should be placed on that tile. And we don't have X and Y coordinates here, we just have 42 images in a list. So we need to calculate which image is this tile, and that is what is also handled in the script. For example, we need to go 7 tiles up in the hierarchy to get to the right image. And if you have watched the introduction to Roller Maze, you may wonder, why don't we use tilemaps here? And the reason is that this game takes place in the UI, and the tilemap feature of Unity is taking place in the world space. So we can't use it here, but we have to implement our own small version of a tilemap here. So let's stop the game for now, and we open the drilling screen. Like I mentioned, the composition of these layers is configurable. The earth layers are not the only thing we can configure in the game. There's a lot more to configure. For example, we can add companies the player can play for, agents they can hire, or tanks they can buy, and so on. And we will take a closer look at that in the next video. If you have any questions left of how these minigames are set up, just let me know in the comments. I hope to see you in the next video. Until then, happy creating and take care.